Good morning, students. Myself Vishwaru Das, Assistant Professor in Civil Engineering Department of Heritage Institute of Technology, and today we are going to perform the test on bitumens. So what is bitumen? Bitumen is a binding material which binds the aggregates together and to construct a road. And so a road, particularly the flexible road, having different layers, like starting from the subgrade layers, then above that is the subbase, then base course, and then bituminous course, and then the wiring course. So the bituminous course, we bind the aggregates together, and it holds the aggregates in positions and take the traffic load that will be moving on the road. So bitumen is obtained from distillation of petroleum crude oil, and we are going to perform today the first experiment is the specific gravity test of bituminous material. So as you know, all of you, that specific gravity is the weight of a material of a given volume divided by the weight of the water of the same volume. So here also the weight of specific gravity of the bitumen will be the weight of the bitumen of a given volume and then divided by the weight of the water of the same volume. So in this we have the specific gravity bottle of 50 ml, which is need to be so first we need to take the weight of that empty specific gravity bottle, which is we can say is W1. Then after that, that bottle is need to be filled with distilled water at room temperature. So weight of the specific gravity bottle filled with water at room temperature is W2. So that we have to take. And then next, the weight of the specific gravity bottle with the material that will be filled in that specific gravity bottle, and it will be about 50%. The bottle will be filled with by 50% of the material, and that weight is W2 here, and then weight of the specific gravity bottle with material plus the rest of the volume that is there, that is planned to be filled by the water. So in that case, we have to take the weight of the specific gravity bottle with material plus the water. So that is W4. Now the specific gravity is the weight of the material of a given volume divided by the weight of the water of the same volume. So here W3 minus W1, what it is? W3 is the weight of the specific gravity bottle with material, which is W3, minus weight of the empty specific gravity bottle. So that will give you the weight of the material, binding material. So this is what it is. And then divided by, it will be the weight of the water of same volume. So weight of the water, so W2 minus W1, what is that? W2 is the weight of the specific gravity bottle filled with water. It is completely filled with water, minus the empty weight of the specific gravity bottle. So that means that will give you the net weight of the water that is completely filled, but not same. The volume is not same as the bitumen material. So for that, need to deduct this amount. So what is that? W4 minus W3. So what is W4 here? W4 is weight of the specific gravity bottle with material plus water. So it's 50% filled with, say about 50% is filled with material and the rest is water. So that weight minus W3. So that is the weight of the specific gravity bottle filled with material. So that will give you the extra water that is there, the weight of the extra water. When we deduct that extra water from the weight of the water that is a full volume of that specific gravity bottle, So that will give us the volume, weight of the water of the volume same as the bituminous material that was filled in that specific gravity bottle. So that will give you the specific gravity of bituminous material. So mainly it is the specific gravity of bitumen that will be used to convert the bitumen from weight to volume on volume basis if it is measured as volume. And then also the specific gravity indicates the source of the material from where it came, and also some kind like the penetration value of bitumen is higher. In that case, the specific gravity can be a bit lower. So normally for pure bitumen, the specific gravity varies from 0.97 to 1.02. So in that range it varies. And now our TA, Mr. Suryadipta, so he will be demonstrating the test. Thank you.
Good morning, students. My name is Suryadip Dasgupta. I am the technical assistant of the Civil Engineering Department of Heritage Institute of Technology. What sir has been discussed regarding the specific gravity of bitumen. So first of all, I want to state that while you are testing in the lab with the bitumen, first of all safety measure is required. So that's why I am wearing these gloves in my hands, I am wearing the shoes, and due to pandemic situation I am wearing the face mask. So I can't remove it right now due to this situation. So now I am going to perform the specific gravity test of bitumen, and so that's why I am take the weight of the empty bottle or specific gravity bottle for as per instruction given by the sir in this board. Okay. So now I am going to take the weight of the empty specific gravity bottle, that is W1 gram. This is our empty specific gravity bottle, capacity of 50 ml. Okay. So now I am going to take the weight there in the weighing balance. So now I am taking the weight of the empty bottle, that is empty specific gravity bottle. Here it is the weighing balance and the weight. Now I am taking of the empty specific gravity bottle, that is 0.046 kg, means 46 gram. Sir, can you please 46 gram. So the weight of the empty specific gravity bottle is 46 gram. Now the second point is that weight of the specific gravity bottle filled with water. So now I am going to fill the bottle by water. Okay, and after that I am taking the weight of the bottle. Now I am going to pour the bituminous material, hot bituminous material inside the specific gravity bottle, and it should be filled half of the bottle, more or less 50%. Now I am putting the lid of the bottle. Now it is very much heated, has become because inside the bottle there is a hot bitumen, so I am just cleared the air bubbles outside of the bottle, and now I am going to take the weight of the bituminous material with the specific gravity bottle. Now the weight is 76 gram, as because I am taking 50% of the material. Now my next work is to add left 50% by water, that is our W4 gram weight of the specific gravity bottle with material plus water, that is left 50% we have to fill by water, that is W4 gram. So after 50% pouring of the bituminous material, the left half of the portion is filled with water. Left half of the portion is filled with water. So now 50%, more or less 50% water is there and 50% bituminous material is there. So after that we are taking the total weight of the bottle plus material plus water, that is our W4 gram, which is coming 104 gram. So now sir will calculate and show the calculation in the board.
Good morning, students. So, as you see, our Surya sir demonstrated this test, and then we got weight of the empty weight, which is 46 gram. Then weight of the specific gravity bottle filled with water, that is 102 gram. Then weight of the specific gravity bottle with material, which is 76 gram. Then weight of the specific gravity bottle with material plus water, that is W4, which is 104 from the test. And then the specific gravity, which is the weight of the material of a given volume divided by the weight of the water of the same volume. So that is, using this formula we can get it. So we have weight of the W3, which is weight of the specific gravity bottle with material, which is 76, minus 46, which is the empty weight of the bottle. So that will give us 30. And then here is W2, which is the specific weight of the specific gravity bottle filled with water. That is 102 minus 46 is the empty weight of the specific gravity bottle. So that will give us 56 here, and then weight of the W4 minus W3. So weight of the specific gravity bottle with material plus water, as you see, that we got 104 minus W3, that is the weight of the specific gravity bottle with material. So that will give us 28. So after calculating all this, we will get the specific gravity of 1.07. As I said before that for pure bitumen, the specific gravity comes around within the range of 0.97 to 1.02. But here in our case we are getting 1.07. So that is maybe because some impurities are there in the bitumen, and that's why we are getting a bit higher value of specific gravity. And similarly, this is the first sample, and similarly we can do it for second and third, and then the specific gravity of the specific gravity, you can take the average of that, and then that average value will give us the specific gravity of the bitumen.